visualizing the data, or how the data has been visualized, the numbers. We have seen the example about correlations. While we visualize the data, we find that there may exist a correlation between the different variables. We put this on recording. There may exist a correlation between different variables. We took an example of the age and the scores in a student transcript or on a course. So this example we have taken from this table. Let me just bring you the table. No, not this one. Yeah. So we have different scores and courses, fine. So that we have taken, and we saw here by this scatter plot of age against the marks, we saw here that on the age and the marks, we see that there is a some evidence here shows in this visualization that a student who has a higher age, okay, has good marks. You can see, with a low age has low marks. Now this is a correlation between these two variables. Okay. So, but there are questions to ask, which is the strength and the significance. The strength is what is the degree of this relationship? In other words, to what extent these two variables are correlated. So into see whether these two are really related with each other. Is it in reality that a student with high age or older students get good marks? And also a significance, is the relationship is real? That is a significance, or it is just a product of chance, or it just by chance it happened and it is not in reality. Okay, these two things should be understandable. For this, we do some statistical analysis. We do some calculations. One of the calculation is correlation coefficient, which is we represent by R. The R value always lies between -1 and +1. Fine. If the R value is positive, it means that there exists this correlation, that in this case, the age does improve the grades. The age does matter here if the R is positive. If the R is negative, meaning that this is by chance and it is not reality. So a correlation coefficient is calculated, and that correlation coefficient is between -1 and +1, any value between -1 and +1. If you see the value as a positive value, then this correlation is correct. It is a right that yes, these two variables are correlated. They have effect on each other. And if the value is negative, then there is no relation between these two, and whatever we see, it is by chance. So that is a correlation coefficient. We don't need to worry about here how to calculate this. It is just we need to understand that yes, there is a variable we can calculate that can show that whether it is in reality or it is by chance by calculating that R value. We do also a significant test to determine whether the probability that the correlation is real or just occurred by chance variation in the data. So this significant test uses that correlation value R. Okay, so done either it is done automatically or by consulting that R value to get a significance value of alpha. Again, the alpha value will be in points. That means, for example, if the alpha value is 0.05, it means that the relation here is 5 out of 100. or you can say 5% out of 100. And then you can decide that it is not an actual real thing, but it is by chance. So we can do a correlation, coefficient calculation, we can do a significance test just to make sure that whether these two relations or two variables are related is in reality or it is by chance. Similarly, we can also do check the relationship between many variables, not just two variables. In our example, we took two variables here, marks and the age, and we try to find whether the age affect the marks or not. Okay, we do the scatter plot, we do calculate the correlation coefficient or significant test to find that. But if you want to do a multiple variable correlation, I mean, you want to check multiple variables, how the variables are dependent on each other, or there is a relationship between the variables or not, we can do that also, and we record that also, their correlation or coefficient values, and we can say whether they are related or not. Just a second, please. It's a prayer call here. So here, correlation between multiple variables can also be calculated, and hence we can also check whether they are related or not. And this table gives some example of this. Let's say we have variables like C1, C2, C3, C4, and C5. I want to check the relationship between these variables. So C1 to C1 is always 1, meaning that it is the same variable. So of course, there is it should be 1. Okay. C2 to C1 has a positive value, saying that there is a relationship. There exists a relation between C1 and C2. C3 with C1 is negative, meaning that there is no relation between C1 and C3. C4 and C1 is positive value. There exists a relation. C4 and C5 and C1 is negative. There is no relation between C1 and C5. So like this, you can see a diagonal matrix here that represents this relation between the correlation between the variables. So that's about the relationship. Then now visualization for descriptive analysis. Sometimes aggregation measure may not tell the whole story. So in that case, we can put that the whole data in a form of pictures or in a form of graphs that will help you to visualize the data more clearly. For example, if we take this data of table 4.2, the student transcript data, where we have the student modules, student taken modules, their credit hours and their marks, and we want to put them into a graph to visualize that student, how many courses the student has above 40 and how many courses the student has a score below 40, then we can put it in a simple graph like this. So with this simple graph, it's very clear here that these are the courses where the student has got above 40, and these are the courses where the student has got below 40. And touching to 0, it means it can be null or 0. Okay, TL172, it's a null. You can see TL172 is a null. So we can visualize this descriptive analysis, what we try to do with the aggregation and correlation and all. We can visualize this as a graph, as you can see here. Okay, so this is visualization. The next thing is comparing data sets. Sometimes it is necessary to compare the data sets. So to describe data sets in comparison to one another. It's always ensuring that a meaningful comparison can be made. That is, the data sets are related in a way the comparison would yield some new information. Then we do the comparison to get some new information. So comparison is also one way to analyze the data. If we take two data sets, or if we have one data set, we can divide this data set into two groups and do comparison to analyze the data. We'll take an example here. For this comparison, we can have two data sets, or we can take one data set and do a segmentation. Segmentation or segmenting data sets is nothing but splitting the data set. A data set is split into separate partitions based on properties shared by all members of each partition. So we do grouping of data sets, which is called segmentation. When we do grouping, we can do comparison between the groups. So one or more groups, one or more operations can be applied on each partition. Segmenting the data in a way have two analytical purposes. One is looking for a shared characteristics of each group, that each group is sharing similar characteristics. Number two, bringing out similarity and differences between these groups. So these are two purposes for doing the segmentation of data set or segmenting the data sets. So through segmenting, we can divide the data and we can look at the similarities and differences between the groups, or we can see grouping of the data sharing the same characteristics. For example, sales team data. We can partition the sales team data. Okay, we can segment this by region, by month, by team members. By region, for example, we have a sales of products, okay, in Kingdom, in Saudi Arabia. And you want to see that sales by region. Medina region, what is the sale? The Riyadh, what is the sale? Dammam, what is the sale? Makkah region, what is the sale? And then we can make comparison. We can analyze it. Where is the sales high? Where we need to send more products? Where is the sales low? So if the sales is low, we need more advertisement. Some analysis can be made and some decisions can be made. So you can take an example of sales team, or you can also take the example of web analytics. For example, how many people are visiting my website? Who are the new visitors who are coming back again and again to my website? We can also group it like that. So segmenting is important here. By segmenting, we can group data into similar characteristics of members of characters with similar characteristics, and we can also understand the similarities and differences between different groups. Like for example, the sales data, partition by region or partition by month, to know which month has more sales of the product, or partition by team members to know which team is doing good. So that is another example. Here you have another example of marketing. So you can go through this example of marketing again. So we'll more see this about segmenting a data set in data warehousing. Segmenting data set. We just understand here the purpose of segmenting with example, but more on this segmenting data will be discussed while we take data warehousing in the coming parts of this course. Working with subsets. So in segmenting, we also do the value segmentation. This is the most basic form of segmentation. Its shared value of attributes determine the segmentation. The values defines the segmentation. That is the value, for example, in the range. Let's say, for example, we want to do the segment of two groups of students. A group of students whose scores in the courses are less than 40. Another group whose scores are more than 40. So this is based on the value, which is 40, which is the score. So this is called value segmentation. So this is done on the shared values of attributes that determines the segments. If you look at this, for example, if you want to segment this into the module codes here that has the average of the marks, we can segment it. Every module with its average. For example, Q224 has, four. We can group this and their marks as their average. We can make it as one group. This course has this number of average. Another course has another number of average. Or we can also see a range of values. For example, how many marks? This course has marks between 40 and 50. This course has marks between 50 and 60 in this fashion. So we can do this segmentation. We can apply the segmentation using SQL. For example, we want to know the module average. We can write the SQL queries like this. Select module code average of mark from mixed module data. Mixed module data is this table name, where module code is QQ233. So it will select the average for QQ233 and their average marks as one group. Similarly, we can make other groups. We can also combine these averages or these data, combining the results by using combination operators like union. We can combine the results to make it one more. Okay. Split, apply, combine process. This is another process where we can split the data and then combine the data like what we did here. Okay. This can also be done by using group by clause of SQL. You will study about the SQL, inshallah, in the next coming classes. Okay. After we finish this data analysis pipeline, we'll go to SQL. So you will study this SQL in detail about select, from, where, and group by, having, joins, and all. Okay. We also have another form of yes, Firas. Have any question? Yes. Yes. What's your question? Union and join. So union here will be working on the data. It combines all the data from both the tables. So this select, if you take this example, which is on the screen, It will give the average for code QQ233 and the average for code QQ224. Union will bring all this in one table. While we are using join, join is like a Cartesian product, or join can be based on some condition. So satisfying that condition and those data which is satisfying that condition will be in the join table. Or if you are not mentioning any condition, it will be a Cartesian product. Cartesian product, it means every data in one table will be with every data of another table. So that will be a Cartesian product. So to avoid this Cartesian product, what we do is that we use conditions on join. Join on some condition. Okay, where union does not hold any condition. It will just bring all the data from table 1 and the data from table 2 into one table. Whereas while we join based on some condition that is called the joining conditions, and the data comes only which satisfy that condition. It can be joined left, it can be joined left, it can be joined right. But in join, there is a possibility that you mention some condition. For example, I want to join the student table with the let's say with the course table. We have a course table and the student or registration table. I want to know who are the students who register in this semester. So there is a table called registration. There is a table called student. The student table has all the students who register, who not register, all the students. Registration table has the students who register and their courses. I want now to know who are the students, the details of the students who registered. So here I can make a join between the student table and the registration table on condition that the student ID, which is in the student table, should be there in the registration table. So here there is a condition that student ID in the student table should exist in the registration table. If it is matching, then that student is registered student. But in union, if I do union of student and registration, it will give me all students who register, who not register, and it will give me all students who register from this registration. So it will be all students register and not registered. But in join, what we just took an example, you get only the student who is matching the ID. It means only the student data who are registered. So in join, you can say that you are getting join based on some condition. And you can also do left join or right join. You want to take the data which is exist only on the left table or on the right table, okay? Or you want to do join based on some condition. That is also possible. In union, you don't have that conditions. In union, you just simply get all the data from both the tables. You're welcome. So union can be used here to combine the results here, just to see the subsets. Binning is again one way of segmenting. Bins are nothing but buckets where we can arrange the data in groups like segmentation. So binnings are done based on some values or some data, or for example, from some range of values. For example, you can take age ranges. Okay, so age from 14 to 24, and then from 25 to 34, like this. So you take groups of ages. Okay. So every group is a bin which will have the data in that particular bin. So I want to know the citizens of Saudi Arabia whose age from 14 to 24 and their characteristics. So that will be made it as one bin. The citizens of Saudi Arabia from 25 to 34 as one bin, from 35 to 45 as another bin to study their characteristics, to study their let's say their way of living the life or something like that. So binning is nothing but again the segmentation where we group the data. Binning is non-reversible process, so thus it means that you may lose the data unless you make a backup for this. In binning, we need to ensure the fence post. Fence post is nothing but the fence values. Fence values, it means the boundary values. If I say, for example, the age from 20 to 25. So whether 20 and 25 are included in the bin or not included, it is inclusive or exclusive. That we need to define in binning while we define the bin. So if I say a bin or a bucket to hold the citizen data from 20 to 25, from the age between 20 and 25. So in that case, whether this 20, if a person age is 20, it is included in this bin or not. If the person age is 25, it is included or not. So these values are fence post. So fence post values need to be defined whether they are inclusive or exclusive. These are also called the boundary values. So they must fall in the bin or they must not fall in the bin. That should be decided when we create the bin. We also have fuzzy classification. Fuzzy classification is again based on some one or more values. In fuzzy classification, we don't have any fixed values. Rather, we go for some, you can say some values depending on, it depends on, for example, on that particular region or on that particular community or on that particular area, for example. For example, if we say that a person is tall or very tall or medium or short. Now, if we talk about, for example, in India, a person is very tall if it crosses, let's say, 6 feet. But if you take the same thing in other countries, very tall is someone who is having more than 7 feet. If you take that to Indonesia, for example, or Philippines, very tall is nothing but someone who has height of 6 feet. Okay. So now a fuzzy classification is done based on the percentage values. What percent we'll call it as a very tall and what percent we call it as a tall or what percent we call it as a medium or short or very short. That is a fuzzy classification. Fuzzy classification can also be done in segmentation. Imposed bins are nothing but the bins which is decided in advance, So for example, you can see here the bin 1 for the ages like 20 to 23 is bin 1 and 24 to 26 is bin 2, 27 to 32 is bin 3. So these are already decided. These are called imposed bins. In imposed bins, we can have equal frequency bins. For example, we take this frequency, equal frequency, like 20 to 23 and 24 to 26. You see there's equal number of frequencies to be taken. Okay. Now here we see that this is a 4 and this 3 and this is more than 3, like 6 or 7. So it's not equal frequencies. So we take that with the equal frequency of ranges, we can create the bins to study the data or to analyze the data. Problems with equal frequency bin. In this case, it might prove impossible to allocate some meaningful fence post. Some ages, for example, age 14, 20, 30, where to allocate. If you take this example, 14 has no bin. Okay, 30 can be put in bin 3. Okay, so in that case, in this equal frequency or imposed bins, it is sometimes it may not allocate the population into the bins. It may discard the population or the data sets. So that is about the descriptive analysis. So in descriptive analysis, we just look at the data and we try to understand what is there in the data, or try to listen to the data, but in different ways. So for that, we can do what we call we can do the aggregations, okay, or we can display the data in a form of graphs. And further, we can do segmentations to analyze further in descriptive analysis. Okay. Now, the next analysis is inferential analysis. Inferential analysis is to reach some conclusion beyond the data. To reach some conclusion beyond the data. That is an inferential analysis. Inferential analysis to judge the hypothesis. For example, we say that for example, a person who studies mathematics will be good in programming. Now, to prove this, we take the data of the students who are good in the mathematics and their scores in programming, and we prove that this is true, that the students who are good in mathematics do good in programming. So in that case, this is what an inferential analysis is. And we can say that, okay, who are weak? From this, we can decide a decision. We can make a decision that the student who want to learn programming must be given mathematics courses before they go to the programming. So this is what the inferential analysis is. So in inferential analysis, data is used, okay, here to make those inferential analysis. Data is extensively used to support the business process and transaction, and also in research. So in research also, they draw the hypothesis and do the research. So data is used here. When considering the user requirement for data management to support research work, it can be useful to know something about research design also. Let's talk about the research. Even in the research, the inferential analysis is a powerful tool to do the research. So in doing the research, what they do is an experiment. So we have experiment and experimental designs. So formal research method tends to be based on one or two types of studies: observational studies and experiments. In observational studies, data is collected in a situation outside the control of the researcher, and it analyzes the data. In experimental studies, data is considered. There is some procedures are given for the data, and draw a hypothesis and test whether this hypothesis is true on that data or not. That is an experiment. So in experiment, it is controlled, the data is controlled by the researcher. Whereas in observational, data is out of control. So in observational, the researcher will just observe the data and draw the conclusions. In experiment, the researcher will control the data, will give some procedures to the data, or will put the data in some procedures, and then it will draw the results. So it can be observational studies or experiment. Now in design of experiment, we can have independent variables as well as dependent variables. So in most of the experiments, it seeks to discover the relationship between the data elements, which is independent variables, and one or more other data elements called dependent variables. The value of independent variables are controlled by the experimenter or the researcher, who seek to establish whether or not the values of dependent variable change in some regular ways in response to change in the independent variables. So that is been tested here. Now we see this by an example. Suppose that a pharmaceutical company has developed a drug to improve the memory in older people, in the old age person. So the medicine is to improve the memory in the older people, and they want to make an experiment. So the experimenter start with a hypothesis, make an hypothesis that the memory improves with application of drug and will gather data. The hypothesis is the memory improves with the application of the drug or with the use of drug. Now, for this, the experimenter will gather data to demonstrate this or to refute this. Okay. This hypothesis, by getting together a group of participants, treating them with the drug and administrating memory test of some kind to them. So it will take a group of participants in this research and give this drug to these participants and make a test to check whether their memory is improving or not. So whether it will say this, that the memory improves, the drug improves the memory, or it refute it. It says, no, this drug does not improve the memory. So here the independent variable is the application of treatment, and dependent variable is the score of the memory test. So they are related. As the independent variable is the application of treatment, that is the person who is taking the treatment, and their score is an dependent variable. So score depends on the independent variable. That's why the score is a dependent variable. Now there are two possibilities here, within the subject and between the subject. Within the subject is nothing but repeated measure design, that all participants are treated equally and they all receive the drug and they take this series of tests during the treatment. That's like before the treatment or after the treatment, they take the test. So here all participants take the test before the taking the drug and after taking the drug, and we can see their scores and decide whether this drug is improving or not. Another possibility is that between the subject design, which is more common. Here, it makes two group of people participant. One group is called control group, the other is called a treatment group. The control group will not receive the drug. They kept as it is. Treatment group will receive the drugs. And both will be given the test after the treatment, after some period of time, and see the differences. So here, between the subject, it means two groups are making and comparison is been done here. Like what we have seen, the comparisons of the groups, comparison of the segmentations. Okay. So here control group and the treatment group has been created from all the participants. The control group are not subject to the treatment. They are just kept as it is, whereas the treatment group has been given the treatment and their scores are measured after the treatment. So such experiment assume the only significant difference between the group is the drug. The only independent variable to change across the two groups. Subject must be randomly allocated to the control group and the treatment group and must be confident that there is no confounding variables, that is any other factors that may influence the outcome. So there is no other factors except that you are just giving them a drug and you are giving them regular meals for both the group, and you are giving only to the treatment group drugs. The allocation of individual group in such a way that the only difference between the group is that independent variable is one of the most important aspects of experimental design and can extremely be difficult to achieve if the condition being studied is rare or the population group is very small. So in that case, it is not, the experiment may not be effective or it may not achieve the results if the group is very small. The group should be in equal size. Okay. Fine. So after this group, we shape the data. So how we shape the data? We can put it straightforward, like we make the subjects here 1, 2, 3, 4. that is the person who is taking the drugs. There is score before treatment and there is score after treatment. Okay, this is within the subject. That is, there is no group here. It is not between the subject. It is within the subject. So within the subject, all the participants are given drug. So this is the list of participants. This is their scores before treatment. This is their score after treatment, and you can find the average of this and average of this and see the scores. And if the scores are, the after treatment score is high, then you can say that yes, this drug is improving the memory. And if there's not, it is same or less than, you can say that this drug is not improving the memory. If you take between the subject, then you have to mention the groups. Okay, this is the list of subject, then this is the groups that related to the subject, and scores before and after. Okay, one group is receiving the treatment, the other group is not receiving the treatment. Okay, so let's say that group 1 is a treatment group and group 2 is a control group. So you can see treatment group has got 21, 26, control group has got 15 and 16. This is also control group 19, 22, treatment group 24, 23. So you can see that difference is not much. Okay, only difference you can see here in the first participant. In this fourth participant, there is no difference. But you can also see the difference in the third participant, which is in the control group. So if you want to do within the subject or you want to do between the subject, you can make it like this. Or if you are doing scores of tests, I mean more than one test, a regular test between the subject, that is also possible, and to see whether this whether to see the results of this experiment. So you can shape the data either within a straightforward way within the subject, okay, or you can shape the data in a form of groups, that is between the subject, or you can keep the data between the subject and you can measure the data on regular intervals, like you give more than one test, scores for test 1, score for test 2, test 3, and so on. So this way you can shape the data and you can analyze the data in this analysis. Statistics for inferential analysis, that is, statisticians have available for this inferential analysis with some techniques. Among these, use general linear model (GLM) for analyzing for the inferential analysis. So use the GLM has a family of tests that can be done on the data for inferential analysis. So data in the form of scores on a memory test from treatment group and a control group have been gathered here, and we can do some test on it. That is GLM tests. Okay, it is a family of tests. So one of these can be done like to check their mean, as you can see in this graph. So check their mean of control group and the treatment group, and you can significantly say that the mean is high. The mean of treatment group is high compared to the control group. Hence, we can say that yes, the drugs are increasing the memory. Also, we can do some alpha values correlation between the variables, and we can also test the correlations. Okay. We can do the t-test. T-test works by calculating a t-value for the difference between mean of two groups. That is the difference between these two. So you're not going to in detail of how to calculate the t-test. We just say that yes, there is a t-test here to test this, I mean to test this analysis, which is the difference between the mean of two values. And how it is calculated, we're not going to go in detail of it. Other test we can do is ANOVA test, analysis of variances. We can do the test of analysis of covariances, regression analysis, factor analysis, These are all different analyses that can be done on this inferential analysis. The statistical analysis on inferential analysis can be done, on experiments can be done, but we don't have in detail about these. So this is about the inferential analysis. So we have seen the analysis, descriptive as well as inferential analysis, both with numbers. Both what we have seen inferential analysis and descriptive analysis with the numbers or with the data, with number data. We took all the examples with numbers. But what if we have a data in a textual form, in a text format, not as numbers? Can we do the analysis if we have the data in a textual format? Yes, we can do the analysis if we have the data in a textual format. So non-numerical form and text data is always messy. Like, so we need to understand what this text is saying. So when we look at the data cleaning and preparation, we may meet the strings from different format or type, strings that do not meet some expected patterns. For example, dates are represented, how the dates are written in text, how the postcodes are written in text, how the currency is written in the text format. Short forms are used, long forms are used. So different things comes, different problems comes with the text data. So there are a number of analytical tasks that will involve working with the data sets that contain strings. Among them is discovery, which is to discover and mark all the string that contain certain sequence of characters. Then replacement, to find and replace occurrence of a string containing certain substrings with updated versions. And extraction, to extract the pattern matched from the text string and return into it in a variable. So discovery, replacement, and extraction are the steps that are involved in this textual analysis. Discovery, to discover the text patterns. Replacement, to replace some text pattern with another patterns. And extraction, to extract the pattern of interest into a variables. For example, if you talk about genetic database comes with the letters GACT. Okay, so GACT is a pattern. So this text pattern of genetics comes with these letters GACT. So it comes like CAGT or CGAG or something like this. So this pattern need to be understood, and from the text it should be extracted and should be analyzed. Also, like the codes, for example, the post code if you take, or the zip codes you take, or any other codes you take in the text, that also has some pattern. So all of these, what we call it, to find the patterns, we call it as regular expressions. We use regular expressions to find the patterns in the text. So regular expression is simply a string or one or more characters to be discovered within a text or a string. So regular expressions, for example, if we say ABC, ABC will match ABC inside any string. If we say, for example, hello ABC world, so if the pattern is ABC, it will match the ABC here. So it will match these three letters ABC in sequence. First A, then B, then C. Then it will count this is available in the string, or it can extract this. Similarly, we can use dot here as a wild character for anything. For A dot C, it means it should come like A, then any character, then C. So it can be ABC, ADC, A9C, ABBBC, or A9CCC. Sorry, any one character between A and C. Any one character between A and C. So it is not like this. This is wrong, but this is accepted. Generally, if we talk about this one, any character between A and C from B, C, D. That is, any one character from B, C, D should appear between A and C. That text will be taken. So this is what we call it as in regular expressions. So regular expressions can be used to extract the strings from the text by giving that expression This regular expression also used in programming. Finally, reshaping data sets for reporting. This is just one thing about the textual data analysis. Now, reshaping data sets for reporting. For reporting the data, what we studied previously in descriptive analysis and inferential analysis, we can use the same results to report this, to add in our reports. We can put the data in reports in a form of tables, like in a form of rows and columns. We can put it in a long format or in a wide format. We can also put in a hierarchical format. So we can put, for example, a table in a form of like rows and columns like this in our reports. It can be a long format or a wide format. So you can see this is a wide format and this is a long format, both representing the data. This representing the data, a long format, as modules and their points, and this representing the data in a wide format as modules here and their points. So this is a wide format and this is a long format. Similarly, we can represent data in this fashion also. Okay, in our reports, wide versus long format, you can see the same thing over here. Okay, now hierarchies, we can put the tables or in a form of hierarchies. In a form of hierarchies in the sense, for example, if you look at this Olympic medal table, we put it in a hierarchy, like we put a country and their discipline first, and then under the discipline, events that taken under the events, medals they have taken, and the names of the players. So it is like in a form of hierarchy. You have the country here, then in the country you have the discipline. Okay, in the discipline you have, in the country you have more than one discipline. Then in every discipline you have more than one events, and every event has taken more than one medal in every event, and every medal is taken by some player. That is in a form of hierarchy. So you can put that hierarchy in a form of table. So we say USA, then their discipline athletics and shooting, then events in the discipline, medals taken, and who has taken the medal. There is also in a form of hierarchies. Okay, you can see that here in a form of hierarchy. So this is how we can represent the data in the reports. So this is all what we have here for you in the part 4, which is analysis part. So this part is important in terms of analyzing the data, where we talk about the descriptive analysis as well as the inferential analysis, and then we talk about segmenting the data, and then we talk about analyzing the textual data. We touch on analyzing the textual data, and finally adding the data into the reports. So this is all what we have here. If you have anything to ask or any questions, you can ask now.